So for our Sec 3 probability part, if you want, you can use the file that's called probability notes, and you can get review about numbers, dice, cards, coins. You're gonna have also 4 examples. I'm not gonna do those in the video because they're pretty well explained, so you can just go and get the examples there. I'll just review quickly the words. The first word that's really important is it's called probability. What is a probability? You have to remember it's a number between 0 and 1. If it's 0, it's something that's impossible. If it's 1, it's something that's certain. And then between, it's the chance of something happening. How do we calculate it? It's called we're going to be doing the number of favorable outcomes over the total number of outcomes. We're going to be doing some practice. What do we do with that? We do experiments. So what's an experiment? It's a situation involving chances. So we're not sure, but we can have idea of what can happen. An event is one or more outcome of an experiment. So what can happen if we flip a coin? What can happen? Or if we flip it 2 times in a row? The outcome is the outcome is the result of our experiment or trial. Sometimes we call it trial. When we want to describe extensively the outcome, we're gonna start. We're gonna start. We're gonna use the weird bracket like this. So let's say if I flip a coin, what are the outcome? I can get head or I can get tail. So those are the outcome. When you list out the outcome, it's called omega. Omega is the set of all possible outcomes. So you list them all. And when you get an empty set, it's because there's no outcome. You might also see it sometimes. We're going to use the brackets, but we're going to put nothing inside. So it's not the same as 0, right? Because 0 is an answer, but it's really empty. Compatible events can occur at the same time. So for example, if I'm looking at the class right now, and I want to know if a student has glasses or a student has brown hair, they can occur at the same time. Where the opposite, incompatible event, cannot occur at the same time. So for example, if I'm picking a card, I can either get a red or a black, but they cannot occur at the same time. So they're incompatible. And complementary, it's when combined gives omega. So for example, if I'm picking cards and I'm picking a black or I'm picking a red, all together they're giving omega. So they are complementary event. What we're going to be doing with probabilities is calculate the probability of something happening. So in this case, what's the probability that a dart thrown at random will hit the black area? So we're going to write it like this. So probability of black. How are we going to calculate that? Or you know what? We're going to write it smaller because I know you like the quick way, right? So probability of getting black, it's going to be equal to the area of the rectangle minus the area of the blue part, right? The rectangle is all, the whole thing is black, but we need to minus the area of the blue. And we need to do that over the total area. The total area is the same as the area of the rectangle, right? And I'm just going to add a line here so you see it's really a fraction. that's happening here. Okay, so how do we calculate the probability of black? The area of the rectangle is 10 times 6 minus the area of the blue part. Well, we have 3 circles, so it's going to be 3 times. And what's the area of one circle? Pi times r exponent to pi r squared over the total area. That's our 10 times 6. So take your calculator and try it. If you need, you can pause the video because I want you to calculate by yourself to make sure that you can do it. Okay, what do you get? And then check on the slide to see if you got the same answer. Make sure that when you do that, you keep in your calculator the real value, okay? So when you do 3 times pi and you get this, make sure you keep in your calculator all the decimals that come after your 9.42. So that way when you calculate your probability of the black, you're going to get 50.56 over 60. And that's going to be equal, you take your calculator and you divide it, because remember the line, it means divide. So 50.56 divided by 60, and you should get about 0.84, or if you want to turn that into percentages, you times by 100, so around 84%. So that's most of the problem you're going to have to do. Now I'm just going to go quickly over a probability tree, because you might have to do that too this year or next year. So for example, if you have 4 pink balls, 3 red and 1 blue, what's the probability of picking 2 red balls? So the way you do it, when you start, okay, you're going to write, I'm going to have a first pick, and then I'm going to have a second pick, right? And then you can find your outcome after, and you can find your probability. So let's look. When you start, okay, and you do your first pick, you have 3 options, right? We can either get pink or red or black. If you want, you can just use the first letter. And for the second pick, oh, first, sorry, I forgot. If you replace the ball after the first pick, that's really important. So we're going to pick, but we're going to replace the ball after the first pick. Okay, so we pick the first one and then we replace it. So we again have our 3 options here. Okay, and to go quicker, I'm just going to write, I can just write the first letter. So pink, red, or black. Okay, and you're going to get that. You're going to get pink, red, or black for all the other options too, right? So I'm just being lazy here. Does it work? Okay, I wanted to bring them together, but it didn't work. Okay, so you can have this for each. It can be pink, red, or black. Now, what's the outcome? Here, the first outcome, it would be pink, pink. The second outcome, it would be pink, red. The third outcome here would be pink, black, and so on. You can list them all. And how do you find the probability? What's the probability of getting pink? Well, you have 4 pink over 8 balls. So 4 over 8. If you want, you can simplify. 4 over 8 is the same as 1/2. If you put it back in the box and you pick again, what's the probability of getting pink is 4 over, do we still have 8? Yes, because we put it back. It's 1 over 2. So what's the final probability here? It was 1/2. So we had 1/2 times 1/2. So it's going to be equal to 1 over 4. Because remember, when we do fractions, I can write it, I'll show you like this here. If you have 1/2 times 1/2, you multiply the top with the top and the bottom with the bottom. Why is it 1 out of 4? Because if we complete the tree diagram, then we're going to see. I'm going to do it quickly just so you can see the final result. So now you can see I completed all the rest of the chart. Sorry, I made a mistake before. I put black, but it was blue, really. So what you can see is if you add all the fractions here, it should equal 1. Okay, if we put them all in the same denominator and add them all, we would get 1 because that's all the possible answers. Now, what if you don't replace? Okay, if you don't replace after the first pick, what's going to happen? For example, here, if you pick a pink for the second try or the second pick, you're not going to have 4 pink ball, you're going to have 3 pink ball. Out of 7, there's 7 ball left because you did not replace it. So you see it's going to change your outcome. And you see also you might get some result like this, 12 over 56, and you can divide by 4 up and down to get a simplified answer. So if you can, you need to simplify your answer. This one, for example, 6 over 56, you can divide by 2 up and down. Check the last one here. If you pick a blue and you don't replace it, there's how many left? Well, there's going to be 0. So there's no chance that you're going to get blue and blue because there's only one blue, really. Okay? The last part is the combination. So for example, how many combination can you create with 4 digits if the digits have to be different? Do you remember what digits are? Digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's like the letters. In English, you have letters and you can create words. In math, we have digits and we can create numbers. Okay, so we need to have 4 different digits. How many choices do we have? We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 10 digits. Okay, so we have 10 different choices. So when we find our first digit, so we need to have a combination with 4 digits, right? Okay, so for the first digit here, we have 10 choices. For the second one, if the digit have to be different, do we still have 10 choices? Well, no, because we're going to have one less. We used one already. So we're going to have 9 choices. And for this one, we're going to have 8. And for the last one, 7. How do we find the total number? We need to times them all. So take your calculator. Check it out. How many combinations do you think we can make? So you know when you have a lock on your bike or something like that, and you're wondering how many combination we can create. So you should get 5,040 different combinations. What if the digits can be the same? If the digit can be the same. So first imagine you have 4 digits. So for the first digit, how many choices do I have? 10. For the second one, if the digit can be the same, how many do I have? Well, also 10. And the next one 10, and the next one 10. So to figure out the total number, you need to times them. So take your calculator. 10 times 10 times 10 times 10 is the same as 10 exponent 4. and it's the same as 1 with 4 zeros. You can try with your calculator, or you can just figure it out. So that's it with probability. Now you can go get the practice worksheet and practice the numbers that you think would look difficult for you. Have fun!